data. And what we want, we have two kinds of data. We have, let's say, no, I'm going to say we have structured data for the first time. We have a structured data, and the first thing the most simple thing that we're going to try is to have what we say a regression. Let's say to analyze the data and say, put like a line that is the best fits all the data. Can be a line, can be a curve, can be something complicated. But let's start with a straight line. And a straight line, and it means that the next time I put a data, or I try to imagine in its one position, I will say probably will be here. Okay, if I have another position, you say probably will be here. I try to have a model, a predictive model, in order to, let's say, predict what is going to happen. And this is very simple. Everybody knows, I think, more or less can have in mind put of data. The problem is that most of the time those data doesn't fit a single line, can fit a different type of curves, and the data cannot be only in one dimension, can be in 2, 3, multi-dimension. And this is what is difficult. What happens is that you start with linear regression, and after we can have algorithms much more complicated, that is logistic regression, that is, it takes decision of when to fit one type of data, when not to fit another type of data, and this is what we try. At the end, everything that we try is to have a supervised and unsupervised model. What is the difference between supervised and unsupervised model? Supervised model are those models that are already tagged, and unsupervised models that are not tagged. Let's say an example. Imagine that you have the temperature of the city, and I want to try to understand I want to try to see what will be the temperature tomorrow. And I have a model, I put all the data, depending the temperature, depending on the day of the year, I have my curve, and suddenly I say, okay, tomorrow will be, probably the temperature will be this one. This is supervised data. Other thing is I have the temperature, and I have also the amount of people that are walking on the street, and I have also, let's say, the color, the medium color of the trees. And I want to have a model that explains me something. I don't know why. And probably I can find a model that they say that depending on the temperature, depending on the humidity, and depending on the people that are crossing the street, the color of the flowers are more orange than red. This is unsupervised. It means that I don't ask him for something special. I have a lot of data, and I have like clustering the data with this kind of model, more complicated, but with this kind of model, and I can have some information. That's unsupervised. Okay?
Some correlation.
Some correlation, if you want. It's a multiple correlation, it's a clusterization of one thing and another. And this is the two different type of machine learning algorithms that we have. And we have for predictive and explanatory models. Predictive, it means I want to see what is going to happen in the future, and explanatory, I want to understand what is happening. Okay? And we have those kind of, let's say, adjustment of points that can be linear regression or logistic regression. Decision tree. The decision tree is like, I am in a point, what is going to happen? 30% in this direction, 70 in this other. I'm going another direction. What is going to happen? And make a kind of tree decision. I mean, this kind of adjustment, but one step after the other. Okay, I say, I am here, I'm going into this place. Now I'm being in this place, I rebuild of my model, and I have another distribution, and I go ahead and another distribution. I have random forest. Random forest is that when you have a lot of decision trees, you have like a random forest. You know? It's much more complicated. After you have support vector machine that you don't have in one dimension, you have like a plane. You don't want to have a linear curve, but you want to have a plane that is multidimensional plane, and you have support vector machine. And after, the more complicated one that are neural networks. Everything correct? It's more or less easy. Neural network works in the same conception that the neural in the human being. How the neuron in the human being is working in the sense that every time that you look at, for example, you look at something, really your brain brain is not looking as an entity, it's looking only at small parts, it's dividing in small parts, and any single part is activating a neuron, and the amount of neurons that are activating is telling to your brain, okay, this is the projector, or this is the face of someone. It's really a lot of brains that are activating. So at the end, what happened is you have a cell body, you have an axon, and this axon is like activation code. And we are building a neuron pattern in the same way. And the first time that they tried to explain what was tried to put in place a neural network was with a neuron. Neuron was something that is incoming, there is a function that is activation, and there is outcoming. It can be 1 or 0, activated or not activated. It's so easy. So, this is the history of the neural network. The perception was the most simple one. After, they start to build multi-layer perceptions, and after they start to put some signal neurons, and now convolutional networks, and they start to become much, much more complicated. But I'm going to try to explain really in details, because this is very abstract, it's very difficult to understand. Oh, let's try with an example. This is a typical example that we teach at the university when the people are starting. We have this number, we have to recognize this number. How to recognize this number and not to, for us it's very easy to see that this is a 3, but this is an 8, right? But for a computer, it can be difficult. What is the difference in the... So, we try to put really a matrix, and we put here the amount of input that we have in the number. When it's completely white, it's 1. When it's not white at all, it can be a 0.8, 0.7, 0.9, and when it's completely black, it's 0. Okay? This is easy to code. And at the end, when I want to go is to have a program that is telling me that if this idea of a tree is on the output, it tells me only the 3 on. Okay, who is doing? If you can see, this is a matrix that usually is 256, 256. It means that you have 784 dots of entries of incomes. And at the end, you will have only 9 outputs. And you're gonna take functions in between in order to activate part of the number. And those are the deep layers. And depending on those deep layers, the amount of information that you can process and the quality of information you can process is much better now. And between this layer and this layer, you have this activation. Okay, how it works? Imagine that you have this number. Now, we have 28 by 28, 784 numbers, and we have this activation, as I told you. No? I have one of the layers, yeah, is, just a second, this one. Imagine that we have the number 9, and we have two, let me see, I have one activation now. I think the better one is this one, yeah. Okay, what we have to first to do is to train the model in order to put a lot of numbers that are similar to the 9. They say, in this case, when you train a lot of model, we have in this first column a lot of times different patterns, so we can have ones or zeros. Okay, when these guys are telling this one that they are also 1 or 0 in order to go layer by layer and finally tell them that is the 9. Because we divide the layers but different structures. Let's say the 9 is a 0 and a bar. The 8 are two couples of rounds. The 4 is like bar and another 1. So any single layer is in charge of dividing on small pieces. The last one, this last one, is the one that is you are dividing in more big let's say, features. But the one before, perhaps we divide this one in little pieces, and the one before in small little pieces. So the first time you go to the layer, to the first layer, you go to this round amount, and you tell him, okay, this part is activated or not. And of course, if it's a 9, and the one that we are training, and let's say we're putting is a 4, here, this more part is not activated. So it will say, no, it's not activated. So we go to the first layer. If it's not activated, it will not activate the next one. But if it's activated, it will start activation the other ones. So at the end, in the different layers, we try to activate the ones that have the most possibility to stay there. But sometimes we are writing very wrong. So there is only activated piece of them. So we have this function has to tell us, okay, it's not only 100%. So we have in between a function that usually makes the probability that to be one being activated, right? So at the end, what we do? For an image is a little bit more complicated, for a text is more complicated, but it's exactly the same. And at the end, this activation depends on the same thing that machine learning. We have a lot of data, and we have a curve, and we have to adjust, and we have to see if the difference between the curve and the data are a lot or not so much. So is activated or not. We have a kind of threshold, or you say, up this point is activated, below this point is not activated. So it's exactly the same as machine learning, but a little bit more complicated. So when we have an image, we have to transform the image in patterns, small patterns, and we have to see if they are activated. So when, for example, you take a picture of the face, for these recognition faces, what they take is the distance between different parts of your head, and that's the patterns. And every time you have to divide these layers by patterns. And those patterns activate the next layer in order to, at the end, have a result. Okay, I don't know if it's more or less you understand. It's a little bit difficult. To explain very fast. What happened with natural language processing, NLP? We have to do exactly the same, but with words. That is a little bit more complicated. It seems that everybody understands that, or thinks that the images are much more complicated than the words, but it's not. It's the opposite. Mathematically, it's much more complicated to train language than images. Because the amount, the image is like fixed. You cannot have you can have a video, you can have let's say, a movie. But every time that you have the context of the video of the movie is like you have a context that is finite. It's not very, very big, but on a text, the context can be extremely huge. You can have, let's say, the history of humanity, and the context of the nowadays depend on the context of 20,000 years ago. So everything is related, and this relationship, this is something that is very difficult to achieve, have all those relationships. So usually what we do in speech recognition, we have the data without processing, we index the data, and we cut on different parts the data. Those data can also have words. With this, we treat this, we will see, as a vector, and after we can have word, sentence, and abstract thought, doing a recomposition of everything. So it's a little bit more complicated, but that's all. Okay, this is how we build everything, and this is the sigmoid, that is one of the activation functions that we have usually. And this is what is important. At the end, for the whole process of the number, we have one function with a lot of parameters. And those parameters that are there is the one that we tune with all the data that we have. So at the end, we have one function, and when we want to see, for example, we write 7, what kind of number is, we have to put there, and with this, the weights of these functions, it will tell us if it's what number is, if it's a 7, or 8, a 4, or whatever. And this is what is important, because those functions, those parameters are the same that we use for LLMs, for training. And this all amount of parameters that we have in LLMs that usually for images that are less than for LLMs, right? And this is important that those parameters are the, let's say, the training that we do in any layer in order to give them the weight for the active function. It's very abstract to tell everything on 5 minutes, but I hope it gives you some ideas. Okay, that's all that I wanted with for machine learning. Let's back to. So, what we do, we start with neural network, and now happens that the vector model came in 2013. The first vector model was word2vec. And what happened? What is the difference? The difference, as I told you, we have inputs, and those inputs usually it give you you train and you have inputs, and the inputs usually are broken on words and now on tokens that really are no words, are part of the words. And what happened is that they build this as a vector. They have an idea, they say, okay, really, all those amount of data are vectors, so we can use those vectors as if we use any vector in any space, really a high dimensional space, we can use as a vector. So in order to have foundings or see what manage them, is much more easy to use it as a vector. So they put the input as a vector, and after they have those hidden layers that they have those activation functions, and they have this output. And the output, they give the probability of any single word to stay. I mean, when you have a lot of different sentences that you're trying, you train your model with a lot of different sentences. After, if you take a word, let's say man, and you take also another one that's the man, they give you probabilities to stay in one sentence or another.
Yeah, and this is one of the reasons why this is incredibly biased. Like you would say, man is the FileMaker developer, man is the FileMaker developer, man is the doctor, man is the nurse.
Yeah, but
because you look at the probability, right?
Yeah, you look always at the probability. Yeah. But what is the problem of this is that it's very difficult to have the context. I mean, the context, it means to have sentences that are very, very big, or all the context of where you're talking, and this is what this is very complicated, because of course you cannot put here all the context, because it's very big. You want to put some sentence, and after try to build a context. A context, it means that you are writing, being able to have always the same context. I mean that when you're talking about, imagine that I am talking about ball, I am talking also about soccer, and if I ask a question, I only that he give me the probabilities about a ball on a soccer, no ball on handball or ball on a basketball. And this is context, is what is very difficult to manage. So what happened? It appears this, do you remember this paper? And this is what happened. Those guys from Google wrote this paper that's named Attention is All You Need. It means that really we have to pay attention of the context. And it's the first paper who really put in place a model to have this attention, this context, that is really the difference between what it was doing before and what it was doing now. So, the attention mechanism, why it was so good? Because they make something you will see where you can have this context, you can processing the whole context, not only the words that you want to process. Also, because it's very parallel, you can make one structure, then you can parallelize, and this is why before most of the models of machine learning are hardly parallelized, because most of them are very linear. So you can parallelize some of them, but you cannot take advantage of the GPUs. Now, with those models, they start to take advantage of the GPUs and parallelize. This is why our friends of NVIDIA goes up like crazy, because now...
Could you explain a little bit on how they use parallel processing?
How they use, yeah. I will explain you later, because another slide where I can explain. And of course, we have this, they can scale up a lot amount of data, because now when you have the context, you don't have to process the whole data, but you can process part of that and remains the context. That is what's important. Okay, I will explain how you can parallelize. What is this transformer attention is built on? It's built on two things. One that is the encoder, and the other is named the decoder. The encoder is taking the whole data, encode the data, and make this transformation of one very big space on a very small space, on a very small space, so you can handle it. So you have one vectors, you put vectors of everything. Before you have tokens, or you have part of words, and now you have vectors, and this vector you want to put it in a low dimension. It means all of them you put in a low dimension, so you can treat it in a low dimension, so you can handle it. You can very manage, and this process is a recursive process. So you can, basically what you do, I'm going to try to explain because it's very mathematical. I mean, if you have a word, you have a probability the word to have someone on the right, one after and one below. But once you do the probability, you go to the second one, the one that is right, and you take into account the probability of the one before and the one after. And with this probability, you go back to the first one, and you calculate again the probability, and after you go to the second. I mean, you go back and forth in the whole sentence, recalculation the whole probabilities of everything, in order to have one model that gives you the probability of any single word to stay in one chain. I mean, anytime that they process, stay in this chain. And it takes a lot of time and a lot of resources, but it can be parallelized, because any time that they do is like a loop. And you can put this GPUs, this process that is very like a loop, one after the other, you can parallelize very, very well. And this is why you take advantage of the GPUs, because the encoder and the decoder, really, you have to always go back and forth, one after back and forth, and recalculate everything all the time. So this recalculation is big, because we use GPUs. Other cases it would be done much less faster than it is. So the encoder goes in a representation on very small packets, and after you have the decoders. The decoders take this small representation, that's the one that you manage to have all these results, and again can explode and give you, when you ask them, give you the final result, because this is the model that you want, like embeddings for asking. I mean, I have all my information, I have very small models, so I can ask very fast, and when I ask them, they give me the result, and they explode for give me the right, let's say, answers. So it's like, I have a lot of information, I try to manage in a small packet, and after give the information again in big packets. This is why usually the encoding is made, or you use, for something like these embeddings, for created embeddings, you use the encoding, and when you generate, you use the decoding part. Encoding is for embeddings, and you use these embeddings, you transform, and after you generate the result with the with this decoder. So there are many models of LLM that are built. So you train with a lot of data, and these LLM that you train, there are a kind of encoder or decoder. The encoder are very used for classification, sentiment analysis, this kind of thing. And decoder is for generating most part of it. And encoder, decoder, you need both. I mean, it's the time that, okay, I want to have all the information inside, take my LLM, and also ask them questions and give me a result or generate. And this is why you need, for example, for translation, usually is encoder, decoder. So all of those models, depend on what you want, you have to go and try to decide what model is the best, depending. You cannot choose, let's say, an encoder model for generating, because it doesn't work. Also, you cannot use a decoder model if you want to, let's say, have a classification of text. This is why it's important to understand and to know what is the difference, and to understand and to know the advantage of one model or 2023. So you have now all of those models. You have plenty of different models. You have the branch of decoder, the branch of decoder, and the branch of encoder. So you have plenty of models. You can go directly, we will see later where you can take the models and what kind of model you can use. Most of them are open, not the biggest one of the most competitive, but you have very good models that are open, right? So this is a summary. Summary, beginning, a statistical model for NLP is the first one that we use. And after there was the neural network, the first neural network, the transformer is this architecture that start to put these layers in between. And the BERT is the first one who made the vectorization. This is important because BERT is the first step of all the models that you have. And nowadays, there's many times that they are explaining about a BERT model. This is, in fact, a vector model. Vector model, they have many different BERT models, but a vector model. A GPT is a pre-trained generative transformer. I mean, it's a BERT model. It's a pre-trained BERT model, right? So, at the end, an LLM agent structure, you have many things that you have instruction, interface at the agent. At the agent, what it does is, depending what you want, but you have this LLM that is a compact size that has been trained, so you can even ask them or put some data, ask them something, and they can generate your results. So, or they can directly transform or give you embeddings, whatever you prefer. But there's two things also that you have to know. You have to know what are fine-tunings and LLM agents. Fine-tunings is, of course, I can train my system with a lot of data. But in a certain time, I want to focus on one specific data. So what do? I have the last mile, I have this fine-tuning in order to these parameters that we have, you know, this function, activation function, these parameters that were built to fine-tuning in order to be sure that the result that they give me are more focused on one specific data. So how we do? We don't want to rebuild the whole system. So what we do is to these parameters, we fine-tuning the parameters that we have. A lot of parameters, we fine-tuning, giving them training, a small training only with data that we want. So they are specifically, the result will be specifically for this. It means that, imagine that I have the same example than before. I have a lot of ideas about ball, about sports or whatever, and he had half tuning about only soccer. If I ask him, he will give me a result mainly, or on percentage, highly on soccer, because they understand that most of the time the name ball is about soccer. This is the idea. And also we have LLM agents. This is also important because there's many ways. I mean, there's a confusion. Most of the people, I don't expect you have this confusion, but most of the people think that an LLM can calculate something. It cannot calculate. Nothing. I mean, you can use machine learning for doing models, but you cannot use an LLM for a model, because the LLM only think that it takes information. I give you probabilistically the whole. I mean, to LLM, if you ask him how much is 1 plus 1, he doesn't know. If he gives you, it's because someone has done this before. So what happens when you want you to ask them, for example, a news, or you want to ask him something that is easy to understand, but he doesn't has in his model the information. He goes to an agent. I mean, he goes to another place, he takes the information, he goes to the LLM, and with the generative, he gives you the answer. But the information, he grab it for another place. And this is the agent. This is why when you go to Gemini or GPT and you ask for a news, it gives you the news. Gemini no, but GPT no, but Gemini gives you the news because it goes to Google, he asks for the news, and it gives you back, and it generates the information. It doesn't have the information in the LLM. It has the connection. And this is why now they're managing to have connection with many agents, like, for example, Mathematica. Mathematica is a Wolfram software that is named for make equations. So you can ask to solve an equation. You can ask to solve an equation. This is not, the information is not in the database. No, but you can ask an agent, solve the equation, and give me the result back. This is an agent. This is what's important. And the RAG. The RAG is a kind of agent, but it's not really an agent. The RAG is one of the things that they try to put in place, FileMaker, and I hope they will put in place. What is a RAG? A RAG is, I have an LLM, and in this LLM, I want to retrieval information from other places, and with the information that I retrieve, I want to generate something, a result or whatever. Imagine that I have a database with invoices, and I ask him, I want to send an email to the customer telling him that he has to pay me. Of course, the database of invoices is not in the LLM. It's not part of the information of the LLM. So you go to the database of invoices, you search, you find the information, and you put this information in the LLM, and he built the whole email. And this is a RAG. He has a query, he retrieves the information, and he generates what you want. But he needs the information. It's a kind of difference that I've told you before for the agent. Because the agent goes to a system, and the difference is the RAG goes to another database. That probably is your database, whatever. Okay, so we have this scenario for a RAG. I have 10 minutes. Okay, because I want now to go to ecosystem. This is, okay, what do we need to know about LLMs? This is plenty of ecosystem. What is important is for testing, we have the OpenLLM, a huge list of ecosystems. Let me try to, here we have this part, all this GitHub, we have tons of LLMs. You can choose the one that you prefer, but it's important that to understand what kind of LLM, if it's encoder, decoder, or whatever. This is important. So after you have different platforms, the most used is Hugging Face. Hugging Face platform is it has a completely ecosystem, so you can take the LLM that you want, you can put in place, you can code. All of those platforms are built with pipelines. I mean, you code a pipeline one after the other. It's very like a FileMaker, and you can use, most of them are connected to PyTorch and TensorFlow, so you can use Python, you can use also TensorFlow that is built with, a system for deep learning. And you have also Quark, DeepSet, and HiStack. All of them are part of the ecosystem for managing. The only thing that I want to a little bit explain before going through the FileMaker stuff is the cousin similarity. Why I want? Because one of the functions that most of the time we will see now in FileMaker, but you want, is when you have a result. I mean, you calculate, you have your LLM machine, and you write something. The LLM machine, as I told you, is a vector machine, and those vectors are named embeddings. And you also add something, so you have to build the embeddings, another vector, and you have to calculate what is the answer. The answer is taking one vector that you build with your question, and one of the vectors that of the millions of vectors that has the LLM. And what is the only way to do it very fast is to see the angle that is in two vectors. Because in two vectors, we usually in algebra, when we say is the angle of two vectors you calculate with the scalar product. The scalar product usually is you take the components of the vector, you multiply each component by the other one, and you divide by the absolute value of the vector. So it's something that is extremely fast, extremely easy. So if they are aligned, it means that they're exactly the same, and the much the angle is, it means that they're not the same, a different one. So this is very easy to calculate, and this is why I put this on place in order to let you know now when you ask for something to an LLM, the only thing that they have to do is to calculate the cosinus. This is very, very easy because you already has done all the embeddings for your system. This is the big calculation that they have to do, but doing the embeddings for your question is also very easy because usually your question is not very big. Of course, if you put a prompt extremely large, probably it takes you a little bit, okay? Now, I'm gonna be on what you have to do on FileMaker. I have 5 minutes to do it, how to install the FileMaker and how to take advantage of all of this. First of all, you have to install the FileMaker server. This is easy. One thing that you have to take into account that careful to remove the server if it has already removed because otherwise it can install. And you have to it's very important to have your certificate and you put your certificate. Why is very important? Because when you connect to OpenAI, they have to verify that you are really the person that you think you have. So this is a problem because if you have a certified, for example, I am from Bitwork. I have my certified from Bitwork, and I have to tell to the, let's say, to the world that my certified match with my IP. So I have to stay in the IP with the certified node. When I ask OpenAI, they go and verify that I am in the same IP that I ask is. So this is a little bit a pain in the neck because sometimes when you are traveling and you have IPs that are moving, you have to go through VPN, right? But it's not a big deal. After, you have to install the Conda. The Conda is an environment for coding Python. Why? Because really what we're gonna do is FileMaker gonna talk with Conda, and this Conda that has some structure in Python is the one that's gonna communicate with OpenAI. So we have to install this mini Conda. In this case, I don't think, I really follow the rules of FileMaker, but I don't know if really you have to install the mini Conda, you can install the full Conda, I don't know. In my case, I install the Conda, you have to make a directory, you have to install the Conda, and you have to initialize. This is important because if you don't initialize, of course, it cannot work. And you have to create an environment, you have to tell them the name. It's important to have the name of the environment and activate the environment in order to let it work. Every time that you switch off and off the machine, you have to activate it. When you build, you have to activate the environment. And you have to install Python. Of course, after the Conda, you install the libraries that you need, and you have to install Python. First, you have to restart the server, activate again, and install Python. And create, and now this is the part that depends how you do before can change. You have to create a secure token. Why? Because really the communication between FileMaker and OpenAI is not coming through the authentication that they have in FileMaker. It's not the admin and your password. No. You have to create a token, and this token you have, let's say, to hard coded inside the system in order to communicate to OpenAI. And this token is the one that you send to OpenAI, is the one that they have to give you before OpenAI. So you have to go to OpenAI, you have to have an account, and you have to ask for a token. And this token is the one that you have to put here. So anytime that you communicate through the authentication of the token. No password, no neither other thing, okay? And this is important. So you don't have really to put or hard-coded the user, neither the password. So for creating the token, you have a kind of information that is relatively easy, but it has to be done all with the terminal. It has to be done with the terminal, but there is a folder in the FileMaker with the explanation of how to do it, but it's really important. And what is important also for creating the token depends if you already put or create the what was the name? The certificate. I was not finding the name. If you already create the certificate or not, because at this time you can create the certificate and put it on the FileMaker, but the name of the certificate has to be exactly the same when you're creating here. So it has to match the name of your certificate that you put on FileMaker server with the token, because the token is like is like connected with this certificate, right? So, and after you have to install the source server. Let's say you have to install this, first you have to install the requirements, and you have also to install this server. This is a code that they give in FileMaker to install the source server. The source server, and with Python install everything, right? So at the end, I don't think I wanted to go through the different functions, but I found out that the new version doesn't have all the same function that we gave us to the ATS. So if anybody wants later to ask me about the functions, I can explain you. But if you see, when you say, for example, configure AA account, this is, you understand, is for configuration. LLM request. This is LLM request is like, okay, I want to go to an LLM and request result, but this is directed to go an LLM request. Insert embeddings, this is already yesterday Ian explained you, and perform semantic search. For performing this semantic search, you have to first having this. Let me show you one thing that we did, and it's the last one, because we already, let me say it, okay. Okay, we have a database here that we put this. These are 14,000 records of. This is a client who has, you know, on the newspapers, on the digital newspapers, at the end, of the bottom of the pages, there's a small news that are kind of funny or whatever. This is the guy that are always writing those news. And those news has a title, those are the titles of the news, and always they ask us what is the best title that they have to put, and what titles are better, and what kind of topic is better, and we have this kind of study about. And so we have here the titles. So you can ask them, if you want, these are titles from 2 years ago, because I wasn't able to take from this year, but you can ask them from anything that is there, and you can ask, okay, there was, I mean, I don't know, about what was perhaps the Korean World War, Korea and war, or nuclear war, and you can tell him, okay, I have to connect. Let me try to connect. If I am not connected, I cannot ask anything. Let me try now. Now, yes. So I can ask them, and usually I told them to give me the 10 best results only, because it gives you, depending of the customers, as I told you, and it gives you the best results. And perhaps it takes a little bit to find. Let's say, okay, I have the test, and those are the Korea conflict. Pyongyang threatened to use nuclear weapon and South Korea attacks. Tension in Korea Peninsula due to Kim Jong nuclear test. Tension in Korea Peninsula nuclear test, and those are the results. So you can ask them whatever, they will give you the best, and really is as I am told you, is very useful for many times that you are asking for not special words, but you can even write it. You can ask, oh, tell me what happened with Korea World War, and they will give you the best results. So I don't have much time. I was very, very fast, so if anybody needs more specific details, I know that was not easy. I hope you had understand something, and thank you very much.